Good morning. It's a great honor to be here, and I would like to just share with you a little bit about CIGRE and some of the issues relating to the Global Energy Interconnector and how CIGRE can help support the solution for. What is CIGRE? It's a global expert community, which means that it's open access and it's free exchange of information. The purpose really is knowledge sharing, whereby we will, from a global point of view, enable the provision for sustainable electricity for all. This is really how we provide the base engineering technology from global input from global experts to enable provision for sustainable electricity for all. At the moment, we have about 230 working groups, 3,000 experts, and there is a working group looking specifically at the global grid and challenges, but there are many other working groups dealing with issues of the global energy interconnection. What are the issues relating to global energy? The first, as was mentioned, was the political issue. And being from Africa myself, one of the big issues is to show benefit for each country participating, especially in the equatorial regions. We need, when we go over the particular countries with transmission lines, it's very important that we give benefit to the communities living in close proximity to those lines. Without that, we have found in South Africa that it is very difficult to get routes or to get acceptance from villages who do not receive the energy from electricity when lines are passed over their communities. The other issue which CIGRE is looking at is infeeds into weak grids with limited storage. There are particular issues with inertia and then large disturbances if the lines or the connectors fail if you have a single infeed into the particular grid. And this is particularly the case in Africa, including South Africa. Just having a look on the left-hand side of this graph is what our normal synchronous interconnection provides. What we really need in a grid is a lot of green dots. However, if you look on the right-hand side where you have your inverter-based resources, which is your mainly renewable solar and wind, you'll find there's a lot of black and orange dots. And the challenge that we are facing is how to actually operate the grid sustainably and reliably with a large amount of inverter-based resources. And CIGRE at the moment, especially in Study Committee C2, is doing a lot of work and research on how we can actually manage the grid with a large amount of inverter-based resources which provide really low inertia. And the main drive there is to look at how can we utilize the synthetic inertia from HVDC sources so that we can actually ensure frequency response, voltage response, and sustainable grid. What are the future trends? And these are based on the work of CIGRE from the Technical Council. And basically, the inverter-based resource penetration will continue to accelerate. And the reason for that, not only clean energy, but because of the free supply of fuel, which makes economic sense to actually increase the installation and penetration of inverter-based resources. The other thing is that loads and generators will be interchangeable, mobile, and variable. And this is really a challenge not only on the design of the grid and the energy interconnectors, but also from the planning point of view. How do we actually design the grid so that it is robust and can cater for varying locations of loads, varying locations of generators, and that the load may become a generator, such in the case of electric vehicles. And that load may be mobile and totally stochastic or variable. The flow of power will be uncertain. It could be from your main sources or it could be from your load sources, which now become generators. Of course, as been mentioned, is markets, and CIGRE are looking at 4 markets to ensure that the purpose and the support the sustainable flow of energy, so it does not distort the power and revenue. Then the operationability of networks with very low inertia is becoming more and more of an issue. And with the global energy interconnector, this issue really needs to be resolved sustainably. Then the security of supply with power sourced remotely. If we are bringing very large energy pipelines into very weak grids, such as your African grids, you'll find that at the moment it's about 10% of the power from external is permitted to come into the grid, so that if you lose that connection, the grid still remains stable. Now, if we are bringing very large power into that grid area, we need to have solutions so that we do not need to have only a 10% input from external sources, but that this can be reliably. There are 10 areas that CIGRE have identified that need to be looked at simultaneously in the future grid. The first is active distribution networks, which includes your smart grid, PV, etc., wind generation, and of course your smart meters, demand response. There's a massive exchange of information, and you will note there that that this needs to be managed, not only who manages the information, how it is stored, how it is used, and so on. Integration of HVDC and power electronics, not only at the high voltage, but also at the low voltage level. And there's a lot of work being done on MV and LV DC transmission into rural areas. Then storage installation, which can in fact help a lot of the inertia and operational issues. System operations and control, of course, very dynamic systems that we need to manage low inertia systems. Protection, again, wide area protection systems, and of course variable protection relay settings. Then new concepts in planning, the stochastic nature of load and generator. We need new tools. We need increased use of existing infrastructure, especially if you're looking into Africa and other areas where your existing infrastructure may be limited, and there are many ways of increasing the power supply over existing lines, AC to DC conversion, high temperature conductors, and so on. And then number 10, incredibly important, is stakeholder awareness. So how can CIGRE assist the global energy interconnection? We're involved in all 10 aspects mentioned. In addition, we have HVDC, HVAC lines and end stations, HVDC grid, advanced protection systems. We're also working with the World Bank, especially into Africa and Pakistan, to disseminate information into African countries. The operation of the grid with high penetration of inverter-based resources, then operation of the grid with large import of energy into weak grids. What we need to do from a CIGRE point of view is link with GEI to possibly more working group and focus areas, if not already covered. In conclusion, the global energy interconnection concept is supported by CIGRE. The prospect for global community enhancement and improved quality of life is one of the major benefits we will get from the global energy interconnection. But the issues cannot be resolved by only one nation. And that's why we need to work together to actually create the knowledge and technical ability to in fact a reality. So CIGRE is a community ideally placed to bringing experts from around the world to enable the global energy interconnection or global grid to become a reality. Thank you.